All right, so section 3.4 is sort of like the turning point, I suppose. Like it kind of starts incorporating perpendicular a little bit. So notice you have both your parallel lines and your perpendicular lines. So again, be aware that, by the end of this chapter, we're going to have a full kind of like intermixing between our parallel and perpendicular lines. All right. So there's three theorems in this video. I'm going to display them all in Desmos geometry just to kind of bring them to light a little bit. Okay. All right. So the first one says if two lines are parallel to the same line, then they are parallel to each other. So I'm going to start with this in Desmos geometry, and then we're going to see what the relationship between A and C is. How does A relate to C? Right? That's our question. All right. And that's going to be our question here that we're going to answer. Okay. So in Desmos geometry, I'm going to create a line. Now I'm going to cheat. All right. So this is bad form, but I'm going to label this point lowercase a. I should not do that, right? That's a point. It's a capital letter, but I'm going to do that. So they're telling me that lines A and B are parallel. Okay. So parallel line. Here's clicking on A. There. And again, I'm going to call this B. And then they're telling me that B and C are parallel. So now I'm going to do more tools again, parallel line. I'll click on line B and I'll make line C. And the question is, well, what is the relationship between lines A and B? Well, A and B look pretty darn parallel to me. Watch if I move A. Notice how B and C both move. So they're forever parallel. So this solidifies this relationship that if two lines are parallel to the same line, then they are parallel to each other. This idea here is sometimes called transitivity of parallel lines. Transitivity of parallel lines. But notice that idea of transitive, right? So B is the middleman, makes A and C parallel. Only works with parallel lines for this lesson. Okay, next one. So now it says if two lines are perpendicular to the same line, then they are parallel to each other. So again, notice that this does not follow the transitivity of perpendicular lines. It doesn't say perpendicular and perpendicular means perpendicular. It says perpendicular and perpendicular mean parallel. Well, let's see. So we have M and T are perpendicular, and N and T are perpendicular. So let's go ahead and show this. And the question is going to be, well, what's the relationship between M and N, right? They're both perpendicular to T. Let's do this picture. So let me erase this, new construction. Okay, so let's draw M. So this would be line M. Again, bad form, but I'm going to do it anyway. It's going to be perpendicular to T. So perpendicular line. So more tools, perpendicular. Click here, click there. Okay, call that T. And then I think it also says that N is perpendicular to T. So again, create another perpendicular line. Let's do this. Let's emphasize this by creating a point here, and let's measure that angle to show it's a right angle. Boom, 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 right angle box. Okay. Now, let's show that N is perpendicular to T. So more tools, perpendicular. Click on T and put N somewhere. I'll put it down here. Call this N. And again, let's measure this angle here as well. So let's do this one here. I'm going to go this way with it so it's in the same position. And there we go. So we have M perpendicular to T. We have N perpendicular to T. So what's the relationship between M and N? Well, they look pretty darn parallel to me. If you move M, notice that N stays parallel. And again, this idea, look at these two angles. They're corresponding angles. So if corresponding angles are congruent, then your lines will be parallel, and this line T is your transversal. So M is parallel to N, and that's the relationship we see right here. Okay, so there is no transitivity of perpendicular lines. Two lines perpendicular to the same line are going to be parallel. Okay, last but not least, we have a line that is perpendicular to one line and parallel to another. So N is perpendicular to L, and L is parallel to M. The question is, how do N and M relate? Well, let's do this. So N perpendicular to L and L parallel to M. All right, let's see if I can remember that. I'm going to write it down. N perpendicular to L and L parallel to M. Okay, so let's do it. It's always good practice to get into Desmos geometry. So get a new construction. So it says N is perpendicular to L. So here's N. Again, bad form to call this point lowercase n, but that's how I'm going to cheat to label. Let's create a perpendicular line. So more tools perpendicular. We'll call this L. I'll put a point where they crisscross, and again, I will measure that angle to show that it is a right angle. Boom. And now it says L is parallel to M. So now the idea is, okay, let's click more tools, parallel line. L is parallel to M. So here's L. When I click on it, I'm going to create another parallel line to L, and we're going to call this M. So now look, N and M, they intersect right here. Let's measure that angle right there and see what it is. I bet you can guess. 90 degrees. And M and N are perpendicular. So if a line, right, so L is perpendicular to one line and parallel to another, then those two outside lines are going to be perpendicular to each other. So again, L is kind of that common line. If it's perpendicular to one line, parallel to the other, then it makes those two lines perpendicular. Okay, so you're going to see when I do the examples, we're going to draw pictures as part of our answers. Okay, so again, this is good practice at parallel perpendicular symbolism.